Assalamualaikum and good day everyone. So we continue with our second video for consolidation odometer test. So as just now we stopped and here, this is how the graph of the square root time method looks like. So you have the deformation, and I mentioned just now how the height minus the deformation versus the square root time. So alternatively, you also can plot directly the dial gauge reading, but I suppose that plotting the H minus deformation is much more much more easier for you to plot, as you got the and also the square root time. So when you have your data, here, so you plot about 13 of points, because you have a 13 data in here. So what you do is you continue the curve. So from this graph, what you want to obtain is actually the value of coefficient of consolidation, the CV value. So in order to do that, you have to follow the Taylor method to obtain the CV value. So if you follow the procedure that I include in my slides, so you can get the value of square root time at 90 degrees, which corresponds to the degree of consolidation of 90%. So you can get the T90 value, and you also already know the height of drainage, which is the initial height divide 2, because we have double drainage in here. And finally you can get the coefficient of consolidation, or in simple lay term, you get the rate of consolidation, so how fast the consolidation occur in the soil. So finish for the first part. So you get this graph and also the CV. But the next is you need to plot the volt ratio against log pressure graph. Okay, you have to plot a volt ratio versus the log pressure graph. So how you want to do that? So this graph actually need to be done with the laboratory for 24 hours lab, and for 8 days. So don't worry, we doesn't do that in our lab, but we give you the supplementary data. We give you the supplementary data. If you see and refer your manual, so we give you table G1-1 sample data for consolidation test in the manual. So you are given the GS, specific gravity, you are given the mass dry of the soil, the new diameter, new thickness of the test soil sample, and the gauge reading is the factors now is 0.0025 millimeter. So you get the reading. This is the list of your readings for the stress of 8 to 1 to 8, a quarter, half, 1 kilonewton per meter squared, 2 Pascal, and until 16 Pascal, kilopascal, and for the respective time up to 24 hours. It is in minutes, but it's actually equal to 24 hours. So you get the initial gauge reading 4,922, and also the final reading. So what you have to do is get the relationship between volt ratio and also the readings. So from the readings, the gauge reading, so gauge reading now here is representing the deformation. Gauge reading representing the deformation. So all the reading needs to be converted by times the 0.0025. So you get the readings, the deformation in millimeter, and by using that, you can include the readings in this equation. So basically, delta H is the initial reading minus the final reading minus the initial reading. So taken the stress as a 1:8 ratio. So the final reading is 4,843 times the 0.0025 minus the uh, 4,922 times the 0.0025. Or you can also do bigger size, bigger data minus the smaller, because it is asymptotic actually. So delta H times the 1 plus initial work ratio. So um, remember that you already get the initial work ratio in here. So use the initial work ratio that you obtain from the given data from the calculation, and minus ratio to the initial height. So you get the new void ratio. So what you want to do with the results, so you have to check for every different stress. So it means that you have the delta void ratio for different stress. You get 1 2 3, I think 8 of new void ratio, and 8 new void ratio, and also 8 stress. You can plot the graph. So by using the log graph, you can use the void ratio data, initial void ratio, the differences of void ratio with the different stress in here as the x-axis. So you can plot the E-log pressure graph, and from the E-log pressure graph you can get the compression index CC, and also recompression index CR. Okay, so if you refer again to the data given, you need to obtain the value of compression index. So you just pick two different location of value, and you get the slope of the curve, and then you get the CC. And if you still remember, because in the laboratory manual you need to answer and discuss few things about consolidation. So I think you can go through again the consolidation that you learn from the geotechnics, that we have a few different stages in consolidation. So it is initial, immediate consolidation, primary consolidation, and also secondary consolidation. And I think you also have to know how to determine the CC, of course, and PC, the pre-consolidation pressure. So I think that's all for the laboratory briefing for odometer test, and all the best. If anything, you can ask me, and inshallah we'll see you again. Assalamualaikum warahmatullahi wabarakatuh.